ObjectiveC. ObjectiveC is a simple language with syntax and conventions that are easy to learn, especially if you have experience with other object-oriented languages such as Java and C++. If you're a C programmer, you'll find that when you are familiar with object-oriented programming and ObjectiveC, your apps are easier to design and modify. If you're new to programming for iOS or Mac OS X, you need to become acquainted with the primary programming language, ObjectiveC. ObjectiveC is not a difficult language, and once you spend some time with it, you'll appreciate its elegance. The ObjectiveC language enables sophisticated object-oriented programming. It extends the standard ANSI C programming language by providing syntax for defining classes and methods. It also promotes dynamic extension of classes and interfaces that any class can adopt. If you are familiar with ANSI C, the following information should help you learn the basic syntax of ObjectiveC, and if you have programmed with other object-oriented languages, you'll find that many of the traditional object-oriented concepts, such as encapsulation, inheritance, and polymorphism, are all present in ObjectiveC. The ObjectiveC language specifies a syntax for defining classes and methods, as well as other constructs that promote dynamic extension of classes and adaptive interfaces. As a superset of the C programming language, ObjectiveC supports the same basic syntax as C. You get all of the familiar things, such as primitive types, int, float, and so on. Structures, functions, pointers, and control flow constructs such as if, else, and for statements. You also have access to the standard C library routines, such as those declared in stdlib.h and stdio.h. ObjectiveC adds the following features to ANSI C: syntactical conventions for defining new classes, conventions for class and instance methods, syntax for method invocation, called messaging, syntax for declaring properties and synthesizing accessor methods from them, conventions for static and dynamic typing, blocks, encapsulated segments of code that can be executed at any time, extensions to the base language such as protocols and categories. Don't worry if these aspects of ObjectiveC are unfamiliar to you now. As you progress through the tutorial, you will learn about them. If you're a procedural programmer new to object-oriented concepts, it might help at first to think of an object as essentially a structure with functions associated with it. This notion is not too far off the reality, particularly in terms of runtime implementation. In addition to providing most of the abstractions and mechanisms found in other object-oriented languages, ObjectiveC is a very dynamic language, and that dynamism is its greatest advantage. It is dynamic in that it permits an app's behavior to be determined when it is running, that is, at runtime, rather than being fixed when the app is built. Thus, the dynamism of ObjectiveC frees a program from compile time and link time constraints and shifts much of the responsibility for simple resolution to runtime, when the user is in control. The dynamism of ObjectiveC springs from three sources. Dynamic typing enables your code to determine the class of an object at runtime. The ID data type makes it possible to substitute any type of object at runtime. You can thereby let runtime factors dictate what kind of object is to be used in your code. Dynamic typing thus gives your program much greater flexibility than static typing does, although with a trade-off of less strict data integrity. Dynamic binding allows your code to determine the method to call at runtime instead of at compile time. Just as dynamic typing defers the resolution of an object's class membership until runtime, dynamic binding defers the decision of which method to invoke or call until runtime. Method invocations are not bound to code during compilation. As with other object-oriented languages, they are bound only when a message is actually delivered. With both dynamic typing and dynamic binding, runtime factors determine which receiver is chosen and which method is called. For example, a drawing program could define an assortment of graphical shape classes inheriting from a common shape ancestor class. You can invoke a draw method on an object without having to know in advance the object's class and how it will draw itself. Dynamic loading allows your program to add modules of code and other resources at runtime. With dynamic loading, an application can load executable code and resources as they're needed instead of having to load all program components at launch time. This capability enhances performance. The executable code can contain new classes that are integrated with the runtime image of the program. As in most other object-oriented languages, classes in Objective-C support encapsulating data and defining the actions that operate on that data. An object is a runtime instance of a class and contains its own in-memory copy of the instance variables declared by that class and pointers to the method of the class. You create an object in a two-step procedure called allocation and initialization. The specification of a class in Objective-C requires two distinct pieces, the interface and the implementation. The interface portion contains the class declaration and defines the instance variables and methods associated with the class. As with C code, you define header files and source files to separate public declarations from the implementation details of your code. You can put other declarations in your implementation file if they are part of the public programmatic interfaces. These files have the file name extensions listed in the following table. When you want to include header files in your source code, use a # import directive, which is like C's # include directive, except that it makes sure that the same file is never included more than once. Figure 1 shows the syntax for declaring a class called myClass, which inherits from the base class, NSObject. A root class is one that all other classes directly or indirectly inherit from. The class declaration begins with the add_interface compiler directive and ends with the add_in directive, following the class name, and separated from it by a colon, is the name of the parent class. In Objective-C, a class can have only one parent. The instance variables of the class, sometimes referred to as ivers, and in some other languages called member variables, are declared in a code block that is delineated by braces, and declarations of instance variables are optional. Following the instance variable block is the list of properties, not shown, and methods declared by the class. A semicolon character marks the end of each instance variable and method. The syntax for a class implementation is similar. It begins with the add_implementation compiler directive and ends with the add_in directive. Method implementations go in between. An implementation should always import its interface file as one of the first lines of code. As mentioned earlier, Objective-C supports dynamic typing for variables containing objects, but it also supports static typing. Statically typed variables include the class name in the variable type declaration. Dynamically typed variables use the type ID for the object instead. You find dynamically typed variables used in certain situations. For example, a collection object such as an array, where the exact types of the contained objects may be unknown, might use dynamically typed variables. Such variables provide tremendous flexibility and allow for much greater dynamism in Objective-C programs. This example shows statically and dynamically typed variable declarations. Notice the star in the first declaration. In Objective-C, object references must always be pointers. If this requirement doesn't make complete sense to you, don't worry, you don't have to be an expert with pointers to be able to start programming with Objective-C. You just have to remember to put the star in front of the variable names for statically typed object declarations. The type implies a pointer. If you're new to object-oriented programming, it might help to think of a method as a function that is scoped to a specific object. By sending a message to, or messaging, an object, you call a method of that object. There are two kinds of methods in Objective-C, instance methods and class methods. An instance method is a method whose execution is scoped to a particular instance of the class. In other words, before you call an instance method, you must first create an instance of the class. Instance methods are the most common type of method. A class method is a method whose execution is scoped to the method's class. It does not require an instance of an object to be the receiver.